Hello everyone, good morning. Standard 10, subject maths, chapter number 1, real numbers. Okay, you know what is real number? You already studied in standard 8 and 9. Okay, so real number, it means it's a collection of all the rational numbers and irrational numbers. We call it a real number. Okay, let's just take a quick overview of a chapter. Okay, in this chapter we are going to learn all these things. So the first thing is a Euclidean division algorithm. Okay, it means a long division method. Okay, in that long division method, it shows the divisibility of integer, whether that integer is divisible or not. Okay, so the application of this Euclid algorithm is to compute HCF using Euclid division algorithm and finding the properties of number. Okay, now the second thing we are going to learn in this chapter is a fundamental theorem of arithmetic, which means a prime factorization method. Okay, in a prime factorization method, it's nothing but a multiplication of integers. The application of this fundamental theorem of arithmetic is to prove the irrationality of numbers and to check if the decimal expansion is terminating or not. This means we are going to learn in this chapter number 1, real numbers. Okay, it's a very easy chapter. Okay, just quick note down what are we going to learn in this chapter so that you will get idea while revising this chapter. Okay, so Euclid division lemma. Okay, Euclid division lemma. We have seen that it's a long division method. It's a long division method. Now, let's take one example. Say 27. Now I'm going to divide with 3. So 3 9s are 27. I'll get remainder over 0. Okay. Now take another example that 27 I'm going to divide with 8. And you will see 7 I'm going to divide with 8. Okay, so 8 3s are 24. What's remain over here? 3. My remainder gets over here is 3. This is a general division method. Okay, so can you tell which one is the correct one? So 27 equals to 8 multiplied 3 plus 3. Now 27 equals to 8 multiplied with 2. Say 11. Now 27 equals to 8 into 1 equals to say 19. Okay, can you find which one is the correct one? First of all, when you just do this simply multiplication, you will get all these 3 are my correct. All these 3 are my correct. Yes, it's correct. No, only this thing is the correct one. The remaining is not correct. Why not correct? Because when you divide any two positive integer or say any integers, there is only one way to write those integers. Okay, the correct way is this. Okay, when we divide any two integers, there is only one way to write those integers. Okay, so what is the correct way? This one. Okay, so what that way? Okay, in which way we are going to write this one? That way is a dividend equals to divisor. Okay, here this 727 is my dividend, and 8 is my division, and 3 is my quotient, and R is my remainder. Okay, so this is the only way we can write this division. Okay, so the second thing you will observe that my divisor is greater than remainder. My divisor is greater than remainder. We can say that a remainder is always less than the divisor. Okay, now just summarize all these things. What we have learned, that there is only when we divide any two integers, there is only one way to write them, that is this correct one. Okay, the second thing we have observed, that the remainder is always less than the divisor. Okay, so this is nothing but a pair of positive integer a and b. There exists unique pair of q and r such that my a equals to b into q plus r, where r, see, we have seen that r is less than a divisor. Okay, and here we have seen that my remainder becomes 0. So the r can be 0, equal to 0, or less than, greater than 0, but it's always less than the divisor. Say my b is my divisor. Okay, so this is nothing but my Euclid division lemma. Euclid division lemma says there is only one way to write any two integers in a division method. Okay, so that is the method is a division. Dividend equals to divisor multiplied with quotient plus remainder, and remainder is always less than the divisor. So the Euclid lemma says a pair of positive integers a and b, there exists a unique pair of quotient and remainder such that a equals to b into q plus r, where r can be equals to 0 or greater than 0, but it's always less than b, which is my divisor. Okay, now pause the video and note it down. Now the application of Euclid division lemma. Using Euclid division lemma, find the HCF of 130 and 91. 130 and 91. Okay, it's again a long division method, we know that. So what are we going to do is, so the bigger digit we take as a dividend. So the 130, now I'm going to divide with 91. Okay, now divide this number with 91 only. So 91. Now the second thing is we have to divide this one. So again 39. Now the second step says, okay, we have to go till we did not get the remainder 0. Okay, here my remainder is 39. So we have to do the again another step, but we did not have a dividend. So what are we going to do? We taking this divisor as my dividend. Okay, in a second step we are going to take the first one's divisor as dividend. So the 91 over here. Okay, now again we have to divide these things. So now we can divide this step with 2 and get over 78. Okay, now subtract this thing. I'll get over here is say I'm getting over here is 13. Okay, now here again I'm not getting the remainder 0. So what are we going to do? The next the previous one step over here is 39 is my divisor. I'm taking this 39 as my dividend over here. So taking 39 as dividend. Okay, now again just divide it. 39 13 into 33 is 39. Okay, I'm getting the remainder 0 over here. Now I'm stop this one. Okay, here says using the Euclid division method. Okay, now how to write all these things? Now look at over here. First, okay, by Euclid's division lemma, what division lemma says? A equals to B into Q plus R. So my A is a dividend. Okay, so dividend is the bigger digit is my 130. Okay, the 91 divisor. What portion remains in first step, which is 1, and what remainder we left with 39. Okay, now look at the second step again. I'm going to write it this portion only. Okay, so I'm taking this 91 as my dividend. So 91. Okay, in second step 91 I have taken. So 39 means this one. I'm taking this side. What portion? 2, and what remainder we left with? 3. Okay, I'm taking this 13 over here and multiply with 3, and what quotient remain is 0. Okay, so what is my HCF? Whenever we get 0, here we get 0 in the last step. So the last step's divisor is my HCF. So last step divisor is my 0. So here the 13 HCF equals to 13. Now we take another example, so we'll get the better idea how to solve this question. Okay. Say 135 and 2, 5. Okay. Again using Euclid division lemma. So Euclid division lemma says B, A is my dividend, B is my divisor, Q is quotient, and R is remainder. Okay. So bigger digit we are going to take that one as my dividend. Okay, so 2 to 5, divisor is 135. Now just pause the video and try to solve this question. Okay, so we'll start with 1 only. 135. Okay, 90. Okay. Again, I'm not getting remainder 0, so we are going to do the next step. So the 90, I'm taking this 135 as my dividend, and again I'm doing the same thing. Okay, so in the next step, again it's not, we can divide with the 1 only. Okay, now again we did not get the remainder 0. Again we are going to divide this step by the previous one. So 90, so 45, 2s are 90. I'm getting the remainder 0. It means that this last step, whatever is my divisor, it is my HCF. So the 45 is my HCF. Now just write all these things. 2 to 5, 135 multiplied with 1. What remains is 90 as remainder. Now taking this 135 this side and 90 over here. Okay, so again 1. What left with remainder is 45. Again taking this 90 over here. Okay, now 45 over here. 45 is what remains is 0. So this one is my HCF. So HCF equals to 45. Okay. Now your homework questions are: so your homework is using Euclid division lemma. or else algorithm. Okay, we can say both. You have to find the HCF of 4052 and 12576. Okay, you have to solve this example using Euclid division algorithm. Okay, see, a difference between lemma and algorithm is lemma is some proven thing which we are directly using. Okay, so lemma, Euclid division lemma, proven thing is this one. Okay, A equals to BQ plus R, and algorithm it means some certain proven things we are just going to follow that step. We are just going to follow that step. So here I have done some calculation. I'm nothing but doing. I'm following that step over here from this step to this one, this one to this one, this one to this one, and get the solution. Okay. In algorithm, we are just follow certain steps to prove such things, and lemma is some proven thing to solve some problems. Okay. Now, second question, second application. The first applications we have seen that to find the HCF. Now, the second thing is finding the properties. Now, second thing is finding properties. In Euclid division lemma, we are going to learn two things. First is using that lemma we find the HCF, and second thing is finding the properties. Okay. Now let's take one example question. Now show that any positive or integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer, where q is some integer. We have to show that any positive odd integer is in the form 6q plus 1, 6q plus 3 and 6q plus 5. Okay. So, solution. Let A be my by Euclid division algorithm. A equals to BQ plus R. Okay, A equals to BQ plus R. So here A is my any positive integer. So I'm taking let A be any positive integer we always get even number. If you multiply 6 with 1, what will get? 6, which is my even number. If you multiply with this 2, you will get over here is 12. 6 multiplied with 3, you get 18. Okay, in the resultant value you always get an even number. Okay, so whenever we multiply any even number with odd, or I say any even number, you will always get even number in a resultant form. Okay, now the second thing is, whenever we add any odd number into this one, we always get odd number. If you multiply this one and add any odd number, okay, odd number. So the 6 plus 1 will get 7. Here is 12. So 12 plus, take any odd number, 3, you will get 15. Which is the odd number? Take any odd number, say 1, you will get 19. Okay. So by Euclid division lemma, look at over here, BQ plus R. If I'm taking this one over here, so I can clearly find that B is my 6. Okay, so this type of questions, if we're asked, we direct, first thing we have to find is the value of B. The first step is to find the value of B. So let B equals to 6 from equations 6q plus 1. Okay, now we know that R is less than or equals to 0, or again less than my divisor B. Okay, so my R is between 0 less than equals to R less than equals to B. So what are the possibilities came out for my R? Look at my B is 6 and 0. So that 0 less than equals to R less than 6. Okay, so there are so many possibilities. Therefore, R equals to either 0, 1, 2, 3, 4 and 5. Okay. Now take case 1. Case 1. Say R equals to 0. If I am taking X, R equals to 0, I am putting this value in which equations? Okay, so that A equals to 6q plus R. Okay, from this, okay, so my A equals to, and B equals to 6, so 6q only. Now second case, R equals to 1, B equals to 6 only. So the A plus 6q plus 1. Okay. Now case third, R equals to 2. So A equal to 6q plus 2. Case number 4, R equals to 3. Then A equals to 6q plus 3. Now case number 5, R equals to 4. Then A equals to 6q plus 4. Okay. Now case number 6, R equals to 5. Then A equals to 6q plus 5. a even number. So in the first case I am getting is even number. In a second case we have seen that if we add odd number we always get odd number. Here again I am getting even number, and because adding with even number, so I am getting even number only, because even plus even always even. So the even plus odd, we get odd number over here. Again I am getting even number over here. In the last step I am getting odd number over here. Hence prove these things we have to prove now, that so that any positive odd integer is in the form 6 cube. So hence prove. Okay, after this one you have to write this.